So this is the fourth part of the Chevy short box series, and we're just going to be going over the forward drum. Obviously, it needs to be thoroughly cleaned up. There's a ton of clutch material, oil, all sorts of debris inside it. We're going to thoroughly clean this up. We're going to blow out all the oil clocking, get everything completely clean. The first thing we did, though, is we cut off the old Teflon rings, and the Teflon rings are a size to fit ring. These old original ones from GM were completely metal impregnated, shot, and they were also shrunk in. They needed to be desperately replaced. And the way you take these off is you take the ring when it's in a little groove and you push it out a little bit, and you take the razor blade and you catch on to the top of the Teflon ring at an angle and wiggle, 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 and you'll cut right through it. And it's a nice clean cut, and you do not want to damage or nick the receiver groove that these Teflon rings go into. So once those are off and the drum is cleaned up, the next step is you put the resize tool on. And don't mind this is broken. This has literally seen hundreds of transmissions. When these are new, they're about this long, but this has gone through a lot of battles. So you take the Teflon ring, you put it over the top, it stretches it, and you feed it all the way down, and you start at the bottom groove first, and you take another ring, and the next groove, and the next groove, and the next groove. And then once all of those rings are in their receiver, this tool comes off, and then the sizer goes on, and the sizer is tapered, and it actually will, as you put this on the shaft, it'll take this once overstretched Teflon ring and shrink it in and size it to its receiver groove size, and then it's all completely done and ready for when you go to put the pump on and do your final build. But it's extremely important that you always put new Teflon rings in, and these four rings are what separate the overrun clutch, the forward clutch, and the 3/4 clutch, all within their respective little chambers inside the drum itself. If you have a ring that's worn out, shrunk in, or even torn or ruined, you're going to have cross leaking, and you're going to burn up those clutch packs for whatever chamber is actually leaking. So once again, it's very, very important that you replace these. So other than that, that kind of covers that. We will move on to the next step. So the forward drum is all cleaned up and ready to go, and just kind of laid a few things out to kind of give you an idea all what's going on here. Got to put in the O-ring first that goes inside the forward input drum. There's new bearing that goes in on top of the right underneath the forward overrun race assembly. New seal, new or cleaned up and inspected backing and apply plates, new bonded pistons. All of the components are all cleaned up and ready to go. The nice thing about this is that it actually has a number 7 5-tang 3/4 clutch piston drum. So the number 7 is a slightly shorter leg, so I should be able to fit all of the 8 3/4 high energy clutches in that I want to put for the 3/4 clutch pack. So some of the transmissions have a taller 5-tang apply piston leg, and once again the number 7 is the shortest, and so those are the most ideal for any kind of performance 3/4 clutch pack. New overrun and forward steels are going in it. New steels for the 3/4 clutch pack, which I don't have those right now. They'll be in tomorrow. This is a updated Sonics apply and backing plate for the 3/4 clutch. We still got to clean all this up. This has cosmoline and the gel and oils that were inside the bag, so we'll clean all this up real thoroughly. But these are a billet steel, super, super hard apply plate and backing plate for the 3/4 clutch. These will not flex and distort like the OEM stock mild steel ones will. So this, along with extra clutches and steels for the 3/4, along with helper springs to get the 3/4 clutches off quick when you're downshifting or when it's doing a forced downshift from third to second. These springs will get the clutch pack off faster. So there's quite a few improvements that we're going to be doing, as you've just seen, and we will kind of do a few more little videos as this thing's going together, and so you get more of a visual of what's taking place. Lunch is served. Sometimes this little O-ring is a little tricky to get on, and sometimes she just slips right in. There we go. See, it's in their little receiver. That's very, very important. That is an important seal not to forget. Some of these bonded pistons are so stiff, they're harder sometimes to get in than a regular aluminum piston with the lip seal on them. There we go. Okay, that's in. Now this goes in. Now this is the tricky part. There's all different ways of putting this thing in, and you talk to a ton of different builders, you'll get different opinions. But this is the way that I like to do it. Just on this one. The other ones can go in conventionally, but this one here it has to all stay together when you set it inside. And the assembly grease, or not grease, but assembly lube keeps it all together. There, now it all stays together. It's just held by assembly lube, and then when the transmission's in operation, the ATF will melt that assembly lube and it'll be gone and dissipated throughout the transmission, so it won't be an issue. Check this out in a second. And these pistons are sometimes a real pain to get in. Sometimes they'll go right in and sometimes they won't. We got the forward piston in, and now the overrun. Once again, sometimes this all fits together real slick, and other times they want to fight you. So all three pistons are all in, and it took a little bit of work, got them in, and she's ready for the spring retainer and the snap ring, and that goes in over at the machine over there to compress everything down, and then I'll air check it and see how we did. And get it the opening between the two lugs here, and these little lugs, actually there's 4 lugs, there's one there, and there's 2 behind. Those little lugs are what actually hold that snap ring in when the drum is spinning and inertia tries to open the snap ring up. So you want to make sure that it's fully inside that groove and behind the little snap ring. 4 tangs. There it is. Yep, she looks good. So here's the 3/4, and put my finger over, there's a bleed hole right by the input shaft. And the little hissing noise is my little blowgun not making a super tight seal around that opening. See if I can get it in there a little bit better, so it give you a little better demonstration. There we go. See that? And that's the little hiss noise. I got my finger off the little bleed hole, and now I'm putting it over it. And there we go. So 3/4 is real nice. Now the next one is the forward. Once again, my little blow nozzle isn't making a super tight seal around that thing. So that's good. Then here's the overrun. Overrun's good. There we go. Checked out good. We're ready to start loading clutches. Okay, so we're going to be loading the overrun clutches in. And the overrun clutches are going in first. Start with the steel. And the friction. And then the steel. And then a friction. And then the mid plate goes on. And you want to make sure at the side that had the track marks on it from the clutch before, face your new clutches. You don't want to go the rough side that had the wave plate against it. So the side that went against the clutches before goes in next. And then you start with a wave. So the wave goes against the mid plate. And then you start with a steel on top of the wave. And then you start your clutches. Last steel plate. And you should end the friction on top. And then before I put the overrun sprag and race assembly in, I'll just drop this down temporarily just to kind of see where I'm sitting. And I'm sitting right at the bottom of the snap ring groove, which is perfect. That's right where you want to be. So I'll take this back out, put in the seal. That's what seals the input drum or forward drum, whatever you want to call it. The seal will go in and not fight. Push it in so she's flush with the aluminum top. Brand new Ingersoll Rand Torrington bearing. Now it's owned by Koyo, but and there's our input sprag with the new Sonics piece that we just talked about. And you put that in. Rotate, rotate, rotate. Yep. Now we're touching the bearing so she's fully seated. And the backing plate goes on. And lastly, the snap ring. Just about got the forward backing plate snap ring in. They are a stiff bugger. Just take your time with it and don't get your finger pinched. And there we go. She is in. And then give her a little air. For the overruns, which you can't see that because that's underneath the forward hub, but you can hear it. So she's holding air there. Holding air. That's the forward. Okay, got the little Teflon rings over the little sizer tool there. And slip them little babies over while they're kind of stretched out a bit and see how they kind of just go right onto the groove. And they'll kind of take back some of their shape a little bit. Okay, we got the little Teflon rings on the shaft, and I'm going to get the sizer tool. Sometimes this goes really quick and easy, sometimes it doesn't. It all depends on how quick I can get these shrunk back in, but there are times when it's kind of a pain in the tail. So next video will be hopefully all 4 of them are done. So we're building the 3/4 clutch pack right now, and the apply plate that goes in is the new Sonex apply plate. It's made of billet steel, extremely stiff. It's not made of just stamped steel like the original GM ones are. And these also have a little lock tang that locks in for all 5 of the legs on the 3/4 piston. So anyways, that goes in first. Just make sure it's fully seated down. And then a beginning clutch that goes in is a friction. And then we got the steel. You basically just do it back and forth. Friction, steel, friction, steel. And the steels that we're putting in are the 78 thousandths. And the frictions that are going in are the 60 thousandths. And there's going to be 8 of the 3/4 frictions. And once we get the clutch pack installed, then we're going to be installing these helper return springs. 5 of those go in, and that help to keep the backing plate and the apply plate separated, so that way you don't have any clutch drag for all 8 of the clutches in a high RPM application. It's really advisable when you have anything that's going to be turning some RPMs to help get those clutches off, because you don't want them dragging, and they will drag. So it's just a good thing to do. So we got all of the frictions and all the steels in, and then these little helper springs. The body of it's kind of curved a little bit, and those just drop right in. And the open spring side is up. But it's important that you get the orientation right, otherwise you'll bind them. And some guys and some shops don't like to install these, and they remove them. And normally I'm not a big fan of putting these in either, but this is going to be a high RPM application, and we need to be able to get these frictions off as fast as possible when it's doing a downshift, or if you're doing a forced downshift from 3rd down to 2nd. You do not want these clutches dragging on whatsoever. So I'm just going to just do a little final quick little look around here, and then the backing plate goes on. Making sure I'm happy with everything, how it's all sitting. It should be going on here. Yep. So now this goes on, and then the snap ring. When you're putting these snap rings on, don't ever want to pry in where your 5 helper springs are. Do not want to damage those at all. So there we go. Feel the pressure there of the springs. I'll get a final measurement. With a performance clutch pack like this, the ideal, and this is a me thing, the ideal travel that I like to have as far as overall clutch stack clearance is right around 50 thousandths. That's what I shoot for. Some guys out there might say 35 and some might say 65. I like 50. So, I'll measure that, and then that takes care of that part. And yeah, that's it. So a little side note, a little add-on to the 3/4 clutch pack that I just built. There's going to be comments, and I'm sure that, and I do actually get a lot of questions about this, about why I use individual clutches and individual steel plates instead of that kit that the frictions are bonded right to the steel plate. And I don't want to name names, but you guys out there know what I'm talking about. Those particular type of clutches I don't like personally, because they use a thin steel with a clutch bonded on one side of it. And yes, there is a lot more surface area of clutch material that is in that particular updated clutch pack kit. But the downfall of it, and once again, it's my opinion, the downfall of it is that those steels are thin and they can't dissipate the heat, not only because they're thin, but there's a friction bonded to the other side of it. So yeah, there's more surface area, but the clutch pack runs hotter of all the transmissions I've seen and transmissions I've torn down with that clutch pack in it. So once again, it's my opinion only, and everyone's going to have a different opinion on how to build their own 3/4 pack. But I personally prefer the individual clutches and the individual steel plates. And the thicker the steels you can fit in a clutch pack, the better the heat will dissipate out. Now, granted, these steels are right at 78 thousandths thick, but they're a heck of a lot better than the 50 thousandths thick steels in some of the other commercial packs or other performance packs that are out there. So once again, it's just my personal opinion, but I thought I'd add that little note after setting this up. And that's it. So we're checking the 3/4 clutch pack, verifying engagement and pressure and everything else, and she's spot on. And little helper springs retract the clutch pack. You can see that. Little squeak noise as my finger slipping over the bleed hole. And there you go. Yours should do the same thing when you air check it. So we're putting a little bit of ATF on the front planet and just right down the output shaft. And then that goes all the way into the clocking of the rear gear train. That's really all you got to do. And once this thing's fired up, anyways, there's going to be oil going all through the entire transmission and clocking. But this is just something I like to do before I put in the forward ring gear. I mean, the forward drum. Exactly. I think I'm tired. The forward drum and the reverse input housing that'll be dropped in together. I just like to pour some ATF down this before I do that. So we're going to put the reverse input drum on our freshly built forward drum. And usually they just go on real quick and easy. I got the selective washer inside the drum first. I got the brand new Torrington bearing, black side of the race facing up. Extremely important. If you put the race down the other way, you're going to have a world of hurt. You're going to have pump noises, and that bearing is going to disintegrate itself and chew right into the aluminum housing. So make sure black side of the race facing up. So the drum goes on. Usually they're pretty darn quick and easy to do. Rotate it, spin, rotate, spin, bam, just like that. Down, and she's ready to go in. And then in a previous video, I talked about the alto band. So this is a brand new drum, extra wide alto band. So this is actually going to be utilizing pretty much the whole surface area of this drum. The factory OE bands go from about here to about here. And so this is a good solid inch wider. So when you get your transmission in operation, you got to take it easy and give this band a chance to level and surface itself to the new surface on your reverse input drum. If you're putting this on a used drum, you better make sure this is super, super flat. If there's any bows or dishes to this surface at all, this band will die really, really quick, because wherever there's a dish, the lining won't touch. It'll only touch in the high spots, which are typically on the outside, and the outside of the band will burn out, and then the middle side then will start touching the dish, and then it'll burn out, and then you're sitting on the side of the road with no second gear, because it won't shift from first into second anymore because the band linings are toast. So keep that in mind. These bands especially, it has to be preferably a brand new drum or extremely super, super flat, good used reverse input drum. And that's it. So putting the front seal in the pump, and I put a little bit of my special, well, it's not so much special, but it's forma gasket sealant. Just put a little bit on the inside of the housing, just down, just a tiny amount, and then I drive in the seal. I always like to put that sealant down. It just kind of helps prevent any chance of ATF from weeping between the aluminum housing and the outside diameter of the seal. It just helps. So when you drive these in, you don't want to be using a hammer. You want to use some sort of bushing or seal driver. And make sure you're going in as straight as possible, because you don't want to kink or cock the seal and then destroy it. When you hear that pitch tone change, the seal is down and flush, and she's nice and straight, and it doesn't have any bends or bows to it. So that should be a leak-free seal, along with the modified drain back holes that I did in this. It'll definitely will help with any type of weepage or issues with seal blowouts or anything like that. So open the drain back holes up quite a bit, going all the way from the back of the seal all the way to where it changes direction, and then also in the stator half of the pump too. And that was all in a previous video, so continue on. So the input shaft, forward drum and reverse input drum are in. We did not videotape that. Sometimes it's a pain in the tail getting them in, sometimes it isn't. This one fought me just for probably about 3 or 4 minutes, getting the last 2 clutches to spline on to the input ring gear. But basically what you do is you put the whole drum assembly in with the reverse input drum on, where I had splined that on, and you put the entire drum assembly in as a unit and turn and rotate, and you'll feel each set of clutches spline onto that input ring gear, and you'll feel it just go click, 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 click. And then you get to the very, very last one, you'll feel it go clunk. And that is where then the entire drum then is then bottomed out on the input sun gear, and the whole stack assembly is right where it needs to be. Because if you try to force a pump in and you still don't have a clutch fully engaged, you're going to damage that clutch. Plus, if you tried to tighten it up, you wouldn't even be able to turn the input shaft. So it's very important that when you get that assembly down, that you still have, up and down play like that. But the reverse input drum now is bottomed out and set securely on the drive shell. So that part is done, and you're golden when you're to that point. So anyways, we will move on to the pump next.